another fancy name given to the router. The router is the gateway between the private network and the public network. Okay, it is acting as a device to transfer packets from the private network to the public network, and hence it is called as the default gateway. And it always gets the first IP in the network. So my default gateway is 192.168.0.1. My device is 0.7. Okay, so now we'll learn how we can assign our own private IP. So we know public IPs are assigned with the ISP, Internet Service Provider. We have no say in that, but our private IPs are in our control. Okay, so we have complete control over them, and we can assign or change the private IP according to our necessity. So let's talk about that. So how do we change the private IP? So for that, you have to go to your control panel. Let me close these other applications, guys. Just a second. Yeah. So let me go to my control panel for now. And in the control panel, I would have to search for network and internet. So you see there's network and internet there. Click on that. In network and internet, click on network and sharing center. And in network and sharing center, click on change adapter settings. Okay, again, let me show you the path one more time. First, you have to open your control panel. In the control panel, you have to go to network and internet. In network and internet, you have to click network and sharing. And in network and sharing, click on change adapter settings. Now, once you have the adapter settings, whichever adapter you want to change the configuration for the IP address configuration for, right click on that adapter and go to properties. Right now I'm connected to my Wi-Fi adapter. So the Wi-Fi adapter is up and working. Remaining all adapters, LAN adapter, Bluetooth adapter, all are disconnected. As you can see, there's a crossbar over it. So I'm connected on my Wi-Fi. So let me right click on that and go to properties. And in properties, I have to select IPv4. I have to click on OK. Now when I do that, you can notice this gives me two options actually. No, 1 second, hasn't opened yet. Okay, now as you can see, it has given me two options here. One is obtain an IP address automatically. So this is also known as the DHCP server method or dynamic method. So right now my system is getting an IP from a server called the DHCP server. I'll explain what that server is in a bit. Don't worry about that. But just in case, if you don't want to get the IP from a DHCP server, if you want to assign an IP address manually yourself, you have to go with the second option. Okay, where you get the option to assign the IP address of your choice. So now I can give my own IP 192.168.0. Let's say 100. Okay, right now my device is getting the IP of 192.168.0.7. Okay, but I want to change this from 7 to let's say 100. Okay, then I have to specify the subnet mask. This is a class C address, so subnet mask is 255.255.255.0. Default gateway, the first type 192.168.0.1. Now once all these three pieces of information have been assigned, it asks for one last piece of information, which is DNS server address. We have not talked about DNS servers as well. I'll talk about that in a bit. But just in case, if you don't know what to assign here, go to your browser, and in the browser, search for Google DNS server IP. And that will provide you two addresses. First, there's 8.8.8.8, and then there's 8.8.4.4. So you can use any one of those addresses. Okay, come back to your control panel and assign the address here, 8.8.8.8 or 8.8.4.4. Okay, and if you assign any one of them, that also works. Okay, it's not necessary that you have to assign both of them. Okay, any one of them will work as well. Now once all the information has been given, just click on OK and click on close, and with this button it changes your IP address. Now since I'm changing the IP address, guys, our network connection will disconnect for a bit. Okay, don't worry about this. Our meeting will get disconnected for a bit and you will rejoin automatically. Don't worry, but let me show you the changed IP address after we connect back. So as soon as I click on okay, Guys, are you able to hear me now? Am I audible? Everyone?
Yes, it's audible.
It's audible, right? Okay, perfect. So let me go to my command prompt now again and check for my IP address. So if I type ipconfig now you can notice the IP address that is assigned to my Wi-Fi adapter is 192.168.0.100. It's not 0.7 anymore. It has been changed to 0.100. Okay. And if I want my original IP back, if I want my previous IP address back, I just have to go back to the control panel, go to the properties, go to IPv4, and select the first option again. And I hope everyone is connected back. Guys, we got disconnected because I changed my IP address again. So earlier it was 0.100, but now if I check again, ipconfig, I've got my original IP back. Okay, 192.168.0.7. Now, a very important question here is, why do we need this? What is the usage of this? Okay, so in the olden times, guys, if you were the network admin, this was your actual job. You had to actually assign an IP address to each and every system manually. Okay, so if your organization has 10 devices or 20 devices or whatever it is, you have to manually assign an IP to each and every system. And if by chance, if any system got disconnected, or if you're installing a new device, you have to go and manually assign that system also an IP address. Okay, so this is how you have to assign the IP address manually. Now, if it's 10, 20 devices, it's okay, not that tough. But if you're working for an MNC and if you have thousands of systems, and assigning an IP address to each and every system could become hectic. It's quite time taking. It's quite a tiresome job as well. So that is why, to remove this whole process, to remove this manual assignment of IP, you have a dynamic method. Okay, that was the first method, obtain an IP address automatically. Okay, that happens with something called as a DHCP server. Okay, so let's talk about that. What is this DHCP server? What is the DHCP protocol? And how does it assign an IP address automatically to us? Before that, I hope everyone can hear me and the screen is visible, guys. I hope everyone is connected back. Am I audible? Okay, perfect. Ziaul, can you hear me? Chris, can you hear me? Nitish, Vijay. Okay, perfect. Ashish.
Yes.
Girish, Devesh. Okay, perfect. So yeah, so let's talk about the DHCP protocol now, guys. Now, DHCP stands for Dynamic Host Configuration Protocol. From the name itself, you can figure out what it basically does. It is used to dynamically or automatically assign an IP address to each and every system in the network. And that it does with the help of something called as a DHCP server. Okay, now that DHCP server runs a process called the DORA process. So let's assume this is my DHCP server. In our home network, guys, our Wi-Fi router itself acts as the DHCP server. So let's assume this is my router's IP 0.1. Okay, and a DHCP server always has a pool of IP addresses. So it has a pool of free IPs. Okay, so this is the first IP which is assigned to the server. The pool starts from the next IP 192.168.0.2 and goes to the last IP 192.168.0.254. Okay, whenever there's a device in the network, okay, when it selects that option, obtain an IP address automatically, the DHCP server starts allocating an IP address to each and every device through the DORA process. So let's assume this device gets 192.168.0.2 and this device gets 192.168.0.3. So once the IP addresses have been assigned, guys, the pool removes that IP, okay, because it should not assign the same IP again to another device. So the pool now starts at 0.4. Okay, now let's assume there's one more device in the network. I've brought a new device, okay, and on that device I've selected that option, obtain an IP address automatically. Okay, now let me elaborate on the DORA process. Okay, so the first thing that this device does when it selects that option, obtain an IP address automatically, is that this device starts broadcasting a packet. Okay, so it sends a packet to all the systems. Broadcast in the sense from one device, the packet reaches all the other devices. Okay, and that packet is called the discover packet. So it is basically trying to discover where is the DHCP server. So it's asking each and every device, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? So when it reaches the wrong systems, they just don't respond back to it. They just drop the packet. But when it reaches the correct DHCP server, that DHCP server responds back saying, hi, you were looking for me. I am actually the DHCP server and I can offer you an IP address now. So since you're a new device to this network, I can offer you this free IP 192.168.0.4. Once that offer is initiated, your system again says, hi, thanks for responding back. I want to request you that you allocate this IP to me and remove it from the pool because I don't want you to assign that IP to another device again. And when that request is sent, finally the DHCP server sends a confirmation. That confirmation is called as acknowledgement. And with that acknowledgement, that IP 192.168.0.4 gets assigned to this device. Okay, and once it is assigned to the system, it gets removed from the pool. So the new pool starts at 0.5. Okay, and this process of discover, offer, request, and acknowledgement is called the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. And all of this happens in a very short span of time, like around 1 or 2 seconds, max to max. And I'm pretty sure if you have owned an Android phone, you have actually observed this DORA process. So whenever you connect your Android phone to a new Wi-Fi, for a very short duration, you see this message saying obtaining an IP address. Okay, so after you enter the correct password and when you click on connect, your phone says obtaining IP address for a short duration, and after that it says connected. Okay, so during that time period when it says obtaining IP address, your phone is contacting the Wi-Fi router, which is also your DHCP server, and it is performing the DORA process actually. Once the DORA is performed and once your phone gets an IP address, it shows connected. So how many of you have observed that that message saying obtaining IP address? I'm not sure if you have done that or not, if you have observed that or not, but actually it happens in a real time scenario. Okay. Now, is this clear, guys, for everyone? Does anyone want me to explain this again? Any questions or doubts in the DORA process? It's called the DORA process. Let me write it down as well. 1 second. Okay, D for discover, O for offer, R for request, and A for acknowledgement. Okay, this works in the DHCP server. The DHCP protocol runs the DORA process to assign an IP address to each and every system in the network. Is that clear, Chris? Right. So now, coming back to the next part. Which server is called the DHCP server? Again, as I've mentioned, Prakash, the server which contains the pool of IP addresses is called as the DHCP server. In our home network, our Wi-Fi router itself acts as a DHCP server. If you want to confirm that information, you can just go to your command prompt, CMD, and if you type the command ipconfig /all, okay, this command gives you the complete information on each interface. So on my Wi-Fi adapter, if you notice here, this is the IP address for my Wi-Fi router, which is 192.168.0.1, and the DHCP server address also is 192.168.0.1. So both the router and the DHCP server are one and the same device. Okay, and if I go to my browser, and in the browser, if I enter my router's address 0.1, and if I log into my router here, let me enter the password. And once I log into my router here, in the router, if I go to network page, network settings, and LAN settings, you can see it is acting as a DHCP server, where this has the pool of IP address pool starting from 192.168.0.2 to 199. It's not using all the 254 addresses, it is using only up to 199. Okay, so your Wi-Fi router in your home itself acts as the DHCP server. What is /8? What is /16? Oh, that is the CIDR value. We'll talk about that in the next class. Okay. So in Windows, you have subnet mask. In Linux operating systems, you have something called as CIDR. Okay, as an alternative for subnet mask. We have not talked about that. We'll talk about that in the next session. So we have a class for that CIDR value where I'll explain what the /8/16/24 is. Don't worry about it.
Was subnet mask explained yesterday?
Sorry.
Subnet mask was explained yesterday.
Yeah, we talked about subnet mask yesterday, right? As I've mentioned, subnet if not yesterday, even today, I just explained it a few minutes ago. Ashish, we talked about what subnet mask is, where the network portion is assigned all ones, host portion is assigned all zeros. Okay, this is for the computer to understand which IP belongs to which class. Okay, so class A has one network portion and 3 host portions. So subnet mask is 255.0.0.0. Class B has 2 network portions and 2 host portions. So subnet mask is 255.255.0.0. And class C is 3 network portions and 1 host portion. So 255.255.255.0.
Why
Default gateway is the router.
Utility.
Sorry, I didn't get you.
What is the utility of subnet mask?
Again, for the computer to understand which IP belongs to which class. So in your IP assignment part, if you remember when we wanted to assign an IP address to the system, one important property it asked was the subnet mask value. Okay, so when you click on IPv4 properties and when you click on use the following IP, you have to mention the subnet mask here so that the computer understands in that network how many other devices can connect. Okay, because if it's a class C network, only 255 devices can communicate. If it's a class B, 255 into 255. It's a class A, 255, 255, 255. Okay, so the computer understands how many other devices are there in the network with the subnet mask.
Number of devices will depend on the router, no?
Ashish, were you there in the class yesterday?
Yes.
Are you sure?
Yes.
If you remember in the last class, I've mentioned router is only a device which is for performing inter-network communication. To transfer a packet from a private network to a public network. The number of devices that can communicate in a single network depends on the class, where you have 3 network portions and 1 host portion in a class C. How many devices can you connect in this network? From 0.1 to 255. So in each class C network, we can connect a total of 255 devices. Doesn't matter what router you use. If you're using a class C network, it can connect maximum only up to 255 devices. If you go with class B now, there are 2 network portions, 2 host portions. So from 172.16.0.0 to 172.16.255.255. Okay, this is one single network. Okay, so in class B now, you can connect a total of 255 into 255 devices. That's 65,000. And in class A, with 1 network portion and 3 host portions, you can connect a maximum of 255, 255, 255 devices. Okay, doesn't matter what the router is. What matters is which class IP are you assigning in that network to the router. Okay.
So we can assign any class IP, right?
That's your choice. Yeah, Zia. Right, exactly. So it doesn't matter which network you assign in your organization or at your home network. Class C can only connect to 255 devices. Class B 255 into 255. Class A 255, 255, 255. So the most number of connections or most number of devices you can connect are with Class A addresses. Okay, and the least number of connections you can make or devices you can connect in a network are with Class C addresses. Okay, and private IPs are completely in your control, so you can assign whatever private IP you want in your network. Public IP is handled by the ISP. Private IPs are your choice. You can assign whatever you wish to. Okay, is that clear, guys? Everyone?
Organization will have the one public key, public IP, or it can be multiple.
One second, Chris. Let me answer your question number. There's another. Prakash, what are you saying? Your voice is very low.
One organization like TCS, it will have one public key, one public IP, or it can have multiple public IP?
Doesn't have to be a necessary rule that it can have one public IP. You can take as many internet connections as you want. For each internet connection that you take, you get one public IP. Okay.
Okay.
So at your home, when you're taking one internet connection to your router, you're getting one public IP. So in an organization, if they have one internet connection, they get one public IP. If they're taking multiple connections, one for each floor or one for each department, the number of connections they take from the ISP, those many public IPs they have.
Okay.
Okay. 1 second, guys. Right, coming back to this, guys. So Chris, to answer your question, as I've mentioned, you were not there in the classes earlier. So to give you a brief overview, public IP is the IP assigned by your internet service provider. So when you're connecting to the internet, you have an organization called an ISP, which provides the public IP to connect to the internet. In your local home network, you have your multiple devices, your phone, your laptop, your smartwatch, and so on. These devices get the private IPs. Okay, private IPs are your private device IPs. Public IP is the IP used to connect to the internet. As simple as that. Okay, so I'll share the recording once. Just go through it and do this. A lot of these questions can get cleared up for you later. Okay. Right. Zia, or any questions for you up to this point? Perfect. Now coming back to the next part, guys. So coming to, we were done with DHCP protocol. Let's talk about DNS servers now. Okay, so if you remember when you were planning to assign a private IP to your own device, it asks for a DNS server address as well. And we assigned the Google DNS server, which is 8.8.4.4 or 8.8.8.8. Now, what is this DNS server and why do we need it? Okay, so to give you a one sentence answer, DNS server is like the contact book application for websites. Now, I know that doesn't make sense. Let me elaborate on that. So you have a phone, and in that phone, in your mobile phone, you have an application called Contacts. What does that application do? It links each and every contact number with the contact name that you assign to it. Okay, so a contact name like dad has a certain 10-digit number. Contact name called mom has a certain 10-digit number. Contact name called Shoaib has a certain 10-digit number. Okay, now when you call a number, okay, with a certain contact name, your SIM card doesn't care what contact name you assign to it. It is only concerned with what its 10-digit number is and what is the next other 10-digit number it's trying to dial up or call up. Okay, it is irrelevant to it what name you assign to the contact, to the 10-digit number. Similarly, when you go to the browser, and in the browser, when you search for www.google.com, your browser actually is like a contact application. You're trying to contact a server which is hosting Google's files. And this browser does not care what this domain is. It is only concerned with the public IP on which the server of Google's files are being hosted. So google.com is being hosted on a server. That server has a public IP which contains all the files. And this browser needs that public IP. Okay. And to fetch that public IP, it contacts a DNS server. Okay. A DNS server has the record of each and every website. So it knows what is the website, and for that website, what is the exact public IP. So google.com is hosted on this public IP. Bing.com is hosted on this public IP. YouTube.com is hosted on this public IP. Facebook.com is hosted on so and so public IP. So it contacts the DNS server. From there, it fetches the public IP, and from there, it contacts the target server. So if I just draw this out, so this is my device here, and this is my router here. My router is connected to the ISP, and let's say there's somewhere on the internet a Google server, www.google.com. Okay, and this is getting the public IP. It's hosted on the public IP of 1234. Okay, now when I want to contact Google from my system, I use the browser application. So from the browser, I initiate a connection. So from my system, it goes to the router with a private IP. From the router, it comes to the ISP first. From the ISP, it is initiating a request for www.google.com. Now ISP doesn't know where google.com is, so it sends this packet to a DNS server. Okay, so this DNS server, where we entered the DNS server of google.com, 8.8.4.4. Okay, so Google maintains its own DNS servers where it has a record for each website. So google.com is located on 1.2.3.4. It has the address here. Similarly, youtube.com is located on 2.3.4.5, for example. Bing.com is located on 1.1.1.1, example. And now once it knows the address, from there it reaches the target website. Okay, so the DNS server tells your browser what is the exact address or what is the exact location of the website. If DNS servers were not existent, your browser would not know how to communicate with that server or how to reach that server in the first place. Okay, so a DNS server is acting like a contact book application for your websites, where it knows the list of each and every website and the IP address it is linked. If I show you an example for this, I can just go to my browser, not my browser, but my command prompt. And in the command prompt, I can run a command ping www.google.com. Ping is a command to check for connectivity. So what it does is it initiates some packets to that server and waits for a reply from that server. So when I hit enter, you can notice it is sending packets to the server and it is getting a reply back. So 4 packets were sent, 4 packets were received, 0 packets were lost, which means everything is working perfectly fine. And if you notice over here for google.com, it is actually mentioning an IP here, 172.217.163.196. If I copy this IP, Control C, if I go to my browser, and if I paste this IP address here, and if I hit enter, and you observe what's happening? With that IP, I'm actually able to access the Google's website. So actually, this is the server's IP. So this is the IP that we have to enter every single time we want to contact google.com. But we humans are terrible at remembering numbers. So that's why we have assigned the domain google.com for it. Okay. And whenever we want to access it, we can just type this domain name instead. Okay. And the DNS server does the job of linking this domain name with that exact IP address. Okay. So that is what a DNS server does, guys. Okay. And most of the times, our internet service provider, Hibernate or Hathway, whatever it is, they have their own DNS servers with a list of all the domains and the IP addresses. If they don't have it with themselves, they will send the packet to the Google DNS server. From there, they resolve the IP for the website and then they send the packet to the correct IP address. Okay. So this is what happens in a real-time scenario in the background. So in that short span of the duration, when you enter the domain, okay, and when you hit enter, this is what is happening. Packet goes to ISP, from the ISP reaches a DNS server, from the DNS server it goes to the target website. Okay, so this is what DNS protocol is, and it stands for domain name service, linking a domain name to the IP address and vice versa. Is this clear, guys, for everyone? Chris, Ziaul?
Sir, does the DNS server have separate software?
Yeah, it's a protocol, guys. Again, it's a protocol. It has a configuration page where you're linking. You have something called as records, DNS records. So you have host record, MS record, DNS records. So using these records, it stores information for each domain and each IP address linked to it. So yeah, it has its own protocol. A protocol is nothing but a small algorithm or set of rules to perform certain actions. Okay. Just like how we have our DHCP server, DHCP has the protocol to perform a DORA process. DNS has its own protocol to perform this action.
So is there only Google DNS server or other companies also maintain?
Ravi, there's a lot of disturbance from your end. That's why I've muted you. There's a lot of distortion from your mic.
Yeah, I muted.
Yeah. So again, as I've mentioned, Google is a search engine, so it maintains its own DNS servers. Other than Google's DNS servers, you have DNS servers maintained by other search engines as well, Bing or Yahoo or whatever it is. And also ISPs maintain their own DNS servers. And some organizations also maintain their own private DNS servers. So whatever domains and subdomains that organization has, they maintain a DNS server for that internally in their organization. So yeah, anyone can create their own DNS server. Is that clear, Ashish?
Yes.
Perfect. Any other questions, guys, for anyone else? Chris, let me note down your email. It's @yahoo.com, right? In the end, your email is anyahu27cc@yahoo.com, right? Oh, Gmail. Sure. Okay. Sure. I'll send the recording to you. Just no
Yeah,
worry.
I also sent the email address to you.
Yeah, Ashish, I've got your email as well. I'll send the recording to you as well. Oh. And Girish, I hope I request you to attend the demo session once if possible. There's demo uploaded on the DurgaSoft official website. But just to answer your question, we'll be working with tools like Nmap. Okay, we'll be primarily working with the operating system Kali OS. In the Kali OS, we'll work with tools like Nmap. We'll work with tools like burp.scoop, Wireshark, Buster. Okay, John the Ripper, crack passwords, Hydra, and then did I mention burp.suit already? And then there's this other tool, a paid tool called Nessus to perform vulnerability scanning. So these are a few list of all tools we'll be using in our upcoming sessions. Okay. So yeah, whatever is mentioned here, Nmap, Wireshark, Metasploit, Aircrack, NG, John the Ripper, Burpsuit, Nicto, Nessus. These are all the tools we'll be working on in our sessions. Okay. So for more information, let's go through the YouTube video uploaded by DurgaSoft as a demo. So you can just go through that demo as well. Okay.
Yeah, Shoaib, one
yeah.
request. Along with the videos, please also send that notepad file.
I will, guys. So I'm just waiting for the confirmation of the list of all the students who have made the payment. So once I get that, I'll be sharing the notes actually every day. So
Okay.
yeah, Girish, yeah, we'll talk about basics of Splunk as well. Okay, but not on Carbon Black because that is not included in the CH course. But if you have any questions regarding those, you can ask me. I'll be there to solve those questions or answer your questions. Not an issue. Okay, because there's a completely different course for these tools, SOC tools, SOC analysis tools. Okay, CH does not cover that. Okay, so that's a completely different subdomain in cybersecurity. This is a course for people just getting started in cybersecurity. So, but again, if you have any questions in those advanced level courses as well, you can ask me. I'll clarify those. Any other questions, guys, up to this point?
So what is default gateway? I missed the class.
Default gateway is the router, guys, as I've mentioned. If you go to your command prompt and if you type ipconfig, you see default gateway gets the first IP. This IP is nothing but my router. So if I enter this IP in my browser, 0.1, it accesses my browser, my TP-Link router. Okay, so the router and default gateway is one and the same thing, the Wi-Fi router. Okay.
And this subnet mask is for differentiate the devices in the same network.
No, differentiate IPs from different classes. Okay, so class A has a certain subnet mask, class B has a certain subnet mask, class C has a certain subnet mask. It is for the computer to understand which IP belongs to which class. Okay, there's actually one more purpose for subnet mask. It is for a purpose called subnetting, where you can break the larger class values into smaller classes. Okay, so you can make a class B act as a class C address as well. That's a much more very advanced concept in networking. We don't have to go into that depth. Okay, so there's another purpose for subnet mask, which is called as subnetting. Okay, but other than that, the main primary focus for subnet mask is for the computer to understand which IP belongs to which class. Okay.
But what's the use? Okay, computer understands something, but what's the use?
Again, as I've mentioned, when you try to assign your own IP address, Ravi, oh sorry, Prakash, when you want to assign your own IP, you have to let the computer know which that IP, which class it belongs to. Unless and until the computer knows what the subnet mask is, it won't know how many devices could it be connecting to in that same network. So it is only used when you're assigning your own private IP. If you're using a DHCP server to get an IP, subnet mask is automatically assigned to the DHCP server itself. Okay. So practically speaking, the only usage of subnet mask that you'll ever have is when you're assigning your own IP manually to the system. Okay. Other than that, we will never have a necessity to change the subnet mask. Okay, exactly. Right.
Yes.
Manas, no, this is not the first demo class. Before this, we have taken 2 sessions as well. So if you want the recordings of that, you can join again, you can register for the course and I'll be sharing those recordings to you. This is the 3rd class actually.
Okay, Vijay here. Can you hear me?
Sorry, Vijay, your voice is very low. I can't hear you properly.
How about you? Is it sorry? How about now? Is it okay?
Slightly better.
Basics of this networking to be expected, like one more class, or like will it get for 2 more classes or something?
No, tomorrow will be the last class.
Okay, so after that we'll be starting with footprinting and reconnaissance, correct?
No, we have one more class before that. There's some echoing, Vijay. But again, to answer your question, there are 3 prerequisite concepts. First, there's networking, then there's lab setup installation, and then there's Linux commands. So after networking is done, I'm going to show you how to install this application called VMware. If you notice on my screen here, this is the application which we need actually for our practical sessions. So I'll show you how you can install this on your system to have a complete hands-on practical approach to the course. Okay, so we'll learn about how to install this Kali operating system. And this is a Linux-based operating system. So after the installation is done, we'll learn what are the commands to run in Linux. Okay, what is Linux operating system basically? How is it different from Windows? What are the most important commands to run in Linux? Okay, how to navigate the system? Okay, understanding the architecture of Linux. Okay, all that is the 3rd prerequisite. After these 3 prerequisites are done, then we go into the footprinting part. Okay, so tomorrow we'll take one last networking session, okay, which is on Thursday. Friday we will talk about lab setup installation, and Monday we'll talk about Linux. Monday and Tuesday. Okay, Wednesday will be the class where we'll talk about information gathering, footprinting or reconnaissance.
Okay, got that.
Right. Again, guys, tomorrow will be the last demo, so I'm gonna ask the institute to change the link from Friday because we'll be diving into the practical part. I'll be sharing these files. So these files are cracked applications which I can only share with the people who have made the payment. So if you have not made the payment yet, please get it done at the earliest. So yeah, that's it, guys. Nothing further. And I have a list actually. 1 second. I guess 1 second, guys. Stay online. Okay, Ashish and Vijay have paid. So for you too, I can, Vijay, please drop your email as well so that I can share the recording and the notes.
Okay.
Okay, for the remaining other people, guys, as I've mentioned, please make the payment so that I'll share the notes to you as well. Guys, the fees is 8,000 rupees, which you can contact DurgaSoft for. Okay, the number is mentioned for DurgaSoft in the official website. So fees is 8,000. You can make payments and installations as well. Okay, probably 2 installations. And yeah, you have the contact number for DurgaSoft from the official website. Just in case if they do not lift, just give me your details, give me your contact number. Okay, and I'll forward your information to the DurgaSoft Institute. If you have any other queries also, I'm going to mention my contact number here, 76800696768. You can just in case if DurgaSoft does not respond back to your messages also, or does not lift the call in time, just contact me on this number. I'll forward your information to DurgaSoft. Vijay, yeah, you have raised your hand.
Shoaib, like one last thing. Like I don't know anything about your profile. Like what do you do? So can we get acquainted?
Okay, I talked about it in the demo session, Ashish. Again, my name is Mohammed Shoaib, obviously, and I've been working in this domain of cybersecurity since the past 5 years. I worked as a SOC analyst earlier for a company called Black Knights in Hyderabad. So from the year 2019 to 2020, actually 2 years, I worked as SOC analyst, and during that time period, I was teaching as well. But from 2020, after 2020, I've completely shifted to training and certifications. Okay, I'm certified from EC Council. I've done courses as ECSA, EC Council Security Analyst, and before that, I've done CES, Certified Ethical Hacking. So again, I've been training students from the past 5 years in cybersecurity. So yeah, that's a brief overview on my profile.
Okay.
Right. And I'm situated in Visakhapatnam, right? So I don't stay in Hyderabad. So that's why I'm taking online classes. So I belong from the southern Andhra Pradesh region, coastal region. So yeah, that's that, guys. Please drop your email so that I can share the notes. Okay, received it. So yeah, that's it, guys. Nothing further. I'm going to exit the session now, and I'll see you tomorrow at the same time. I'll share the recordings and the notes shortly. Bye bye. Good night.